Hello, this is a recap of some work that we did in class the last week or so, involving the Richter scale first of all, and then involving solving exponential equations using logarithms and other techniques. So this is a great chance to get into some of the more more high-level IB style questioning, where a lot of times we have to do some non-routine thinking and make some inferences and so forth. So in a problem like this one, where we're measuring the Richter scale, it's giving us a description of the function in words, and we have to translate that into something that we can actually work with. The goal here is actually to focus on the communication of mathematical ideas less than the actual calculations. You'll find the calculations relatively straightforward, but the thinking might be the harder part. So the first thing I recognize is my variable relationship. We have a unit on the Richter scale, which is dependent on the strength of the earthquake. How is it dependent? There is a factor of 10 relating these two. So the issue is, how do I actually write that in terms of a function equation? So what I have to do is try to understand the relationship between the variables. And so we have the Richter scale value is a function of the earthquake intensity. That is, it depends on how intense the earthquake moves. Therefore, we can establish that there is a function relationship where the intensity affects the Richter scale and not the other way around. When it says corresponds to an increase by a factor of 10, I could actually develop a T-chart where I have the energy that one earthquake creates to make a 1 on the Richter scale. Now, I don't know how much that is, but what a factor of 10 means is 10 times that energy is required to cause the scale to go up to a 2. 100 times that energy is required to get the scale to go up 1 more. So that's what it means by corresponds to an increase by factor of 10. This represents then a base 10 logarithmic function. So simply put, the relationship between the Richter scale score and the intensity of the earthquake is a logarithmic one. This is just a translation into math, what's being said up here. So, given that the Richter scale score is 5.2, we can imply that 5.2 is equal to the log of intensity. And therefore, we can now use algebra to convert and solve for the intensity itself. So this is now the official intensity of an earthquake that measures 5.2 on the Richter scale. We will now double that intensity, and that will be 2 times the intensity, or 2 times 10 to the 5.2 power. So the value of the Richter scale at double the intensity is the value of the log of 2 times 10 to the 2, or 5.2 power, which is, using our properties of logarithms, we can express as the log of 2 plus the log of 10 to the 5.2, which is 5.2, generating 5.5 on the Richter scale. This is from using a calculator to estimate. So I just make sure that I answer the question. If the question is asked in English, then we answer in English, and the statement here is simple enough. A 5.5 Richter quake is twice as intense as a 5.2 quake. Now, if we were taking an IB exam, all of this writing that I did over here, this is all stuff that we're going to think, and we're going to think that very quickly. But in the process of learning, I'm looking for evidence that this thinking is taking place, and so we're going to think about our writing as more like a lab report. Now, this stuff right here is definitely important, especially when we get into the mathematical equations and expressions. So you don't have to say given, and you don't have to say double intensity and do all that stuff. And IB exams will just basically show what I'm circling right now. But for this course, we're going to dig a little deeper. And here's what else we can do on a regular homework assignment to bolster our thinking and our perception of what's going on here. We can use the technology to create a graph. And what this graph does then is it shows how the intensity is doubled, and that causes only a minor change, 0.3 Richter scale points. So this visual is an excellent way to perceive what increase by a factor of 10 looks like. The next one was to solve an equation. And here again, I want to talk about not just getting the solution to the equation and what algebraic techniques I use, but I want to talk about the opportunity embedded in each problem, to be able to dig deeper and to learn more about all the different techniques in mathematics and how they're interrelated and interconnected. So that's what I'm going to demonstrate here. I'm not going to talk as much through this one because this was gone over in class, but I simply want to point out some of my early thinking is that 7 and 49 are base 7 numbers. Base 7 is going to be the type of logarithm my answer has to be expressed in. So that's the first thing I notice. Second thing I notice is the way the answer is formed implies that there's going to be no calculator used to get the solution. And that's not to say that we shouldn't use a calculator. If we have one, you can graph these and look for the intersection on the graphs, and that will actually give you something that can check your answer with, because you can check it against a plus the log base 7 of b and see if that gives you the intersection that you're looking for on the graph. Anyway, I said I wasn't going to talk, so let's just look at the first approach. I express everything in terms of base 7, and then I multiply both sides by 7, or sorry, I divide both sides by 7 to the 10 minus 2x power. I subtract the exponents to get this exponential equation. Now, to solve the equation, I'm just going to take the log base 7 of both sides, and the left-hand side is inverted, so I'm really getting x minus 10 equals the log base 7 of 3. So, the solution to the equation, when solving for x, we add 10 to both sides. X equals 10 plus the log base 7 of 3. You can see that's in the right form. An integer plus the log base 7 of an integer. A and b are both integers. I've got the solution. I'm pretty sure it's right. But here's where we go above and beyond in the homework process so that we can actually get an extended value for this problem. I'm going to take a different approach. This time, instead of dividing both sides by 10 to the 2 never mind. Instead of dividing both sides by this guy, I'm going to multiply both sides by 7 to the x power. That produces a 1 on the left-hand side, and on the right-hand side, my exponent is increased by 1x. So I multiplied by 7 to the x power. That is, I increase the exponent here by 1x. And now I can divide both sides by 3. That's what I did here. And now I'm going to take the log base 7 on both sides. Solving for x, I end up with this result, which is slightly different. A, 1/3 is not an integer, and B, we're adding and not subtracting. So we have to change this, and that's where we learn about this reciprocal relationship in logarithms. Hold on there, Mr. Doseri. Okay, here we go. Alright, so that is 2 unique methods or approaches to solving this equation. I'm going to go one step further. Some people actually tried this, and normally I wouldn't recommend it, but it's certainly really elegant when you see it all come out. And that is, you immediately take the log base 7 of both sides. Then we can use the product rule to separate the logarithms. Then we can take the inverse here, because these are inverse operations, the 7 to the 10 minus 2x power and the base 7. And over here, these are inverses right here as well. So we continue on, and we get this equation, which we solve for x, and we get the same solution that we had before. Now again, if I put that into the calculator, I'm going to get 1.18 approximately times 10 to the negative 9 power, a really small y value, but my x value is going to be 10.565. So if I put this into a calculator, 10.565. Finally, and I'm just going to share this straight up, you can take the exact form, log base 7 of 3 plus 10, and if you didn't have a calculator to support your work, this is evidence that you can actually put these values in, utilize the properties of exponents, and find the left-hand side to be equal to the right-hand side. So I would suggest either pausing or looking at the PDF of this file and studying what I do here so that I can verify that I'm getting the exact same result for both sides of the equation when I use my solution. Now there should be no doubt that a student who completes even 2 methods out of 3 and then either graphs or, even better yet, uses substitution to verify their equation is correct, there should be no doubt that that student definitely understands what they're doing. If you produce work like this, it's easy to assess. It means you've met the standard and exceeded it. So that's what we should strive for in IB. Enjoy.